Okay. Hello, everyone. Today is November 4th, and we're in the Contour office hours. That's official CNCF meeting, so please follow the code of conduct for CNCF. And with that said, I think we have Steve Slocka prepared something to do a code walkthrough and development environment setup.
Yeah, so I know, Orlin, you wanted to know, hey, how do you develop Contour? How do you build it locally? What do you do? I'm sure for different people, this is going to be different. I can show you kind of what I do, and then hopefully, Sanjay or Steve can pop in with the things maybe they do differently. I know some of the folks in the community who have done some things differently than I guess what I'll show you, but to me, this is probably the most straightforward thing. So let me go ahead and share this. So hopefully you can see, again, I'm on Linux again, so this is always the crucial part. Let me get rid of QVIP here and let's open up Contour. Just swap a doodle. Okay. So I'm using Goland here. I know folks use, you can use VS Code, you can use really whatever you'd like. But when you first clone Contour, I guess the good thing to do would be to have some Git aliases set up. And I'm not sure, I think we have this in our docs. Let me go back to Contour. There we go. Okay, so I'll make this a little bigger. That way. All right. So if you go here, if I go to git remote-v, what you'll see is I've got actually a couple different things. So I have my origin, which I use as my local fork, right? So if you go out to Contour, let me go ahead and pop that open. This is the Contour English controller repo, I guess. If you go here over here to the right and you say, hey, fork, then you can go ahead and make your own copy of it. So that'll make a new repository in your GitHub user, your GitHub org user, and give you that fork, which looks like this. If I click on this, you'll see my fork. This is mine, right? So it's actually pretty old, from 2020, because I haven't pushed main here. But what you can do now, you can do whatever you want in this fork of it. And this will let you send pull requests upstream back to Contour proper if you'd like. So what I usually do is I have my origin be my local, my fork of it, and then upstream is the upstream repo, right? So this is project contour/contour. So once you do that, you can get you can stay up to date by fetching. So again, this is probably where things can get funny. This is what I do. So I'll do a git fetch upstream, and this will pull in basically all the diffs that happened between the last time I did this. So we can see that main was updated, and here's some commit SHAs and stuff, and then I'll just git rebase upstream main. And now at this point, if I do a git log, looks like Taro was the last committer. And if we hop over to Contour, we should see that here, Taro has the last commit here on the repo. So now I can know that I'm up to date because this was the last bit that got merged. This workflow is important as Contour changes and your fork gets slowly behind. This is important to do not only for your forks, but for any branches you might be on. So I know Steve has a big update in review for moving the this one, replacing the dynamic client. It's not a huge change, but it touches a lot of different things. So with this change, once this merges, you may have code that will now have conflicts that you have to resolve. So staying up to date in these things will be helpful that way. Okay, so that is just repo stuff. Anything you want to add, Steve? Does Sanjay leave us?
So far, it's the same exact process I use, same naming and everything. Cool.
Oh, you are, Sanjay. Couldn't see it on my little window there. Okay, cool. So now that you have that, now you're free to like do stuff, right? And there are some, I guess this is where we should probably follow our own docs to see if stuff matches up or doesn't, and if it doesn't, we can update it. There should be a contributing guide out here, and there is, and this is where we can, I guess, start. And this is where things, I guess, they get confusing between pages here on the repo and pages in project-contour.io. But the first thing you're going to need is Go. So you can do that through any number of ways, depending on what OS you have. This page here is pretty simple. I know folks, again, have different ways to switch different versions of Go. On an OS Mac, it's pretty easy. You just run the little installer and it does it all for you. On Linux, you just need to extract some files and do some things, and it tells you how to do that. So pretty much get Go running. I forget what version I'm on. I'm on 1.17.1, so I'm a little behind. Shouldn't matter too much, but that's the first thing. The second thing you'll need is there are some dependencies that come into play that Contour uses that may or may not be an issue in terms of what commands you run. A lot of things that we have are mirrored by Docker containers. So basically, if you have like, there's a linter that runs. If you don't have that linter binary, then the makefile will run a Docker container to do that execution for you. So then Docker would be the other requirement. But Docker is not required to build Contour or anything with Contour. It's just sort of a fallback in case you don't have the right dependencies. We probably should add some more things in here because there are a couple of things I think that might be helpful. But the big thing here is there's a make. And again, this is where we diverge, but you can do a make check. You can do a test, do linting, that sort of thing to verify all as well. So if I go here and I run a make, what does this do? This is probably too big for you. So it's getting dependencies and stuff. It's weird that it's doing so many. Yeah, so make when it's going to run tests. This is running the unit test here. And then it's going to run again with the race condition. So I'm not sure what to do both of these anymore. We should see. That would help speed up things. We had an issue like a few years ago where we had a race condition and how things got updated, and it caused Contour to crash. And we found out by adding this -race. And that's why this exists. So this runs the tests, right? So this is helpful. Again, a number of ways you can do that. From my IDE here, I have a little button here I can click once this updates. Then I can just run my test here and I get a nice little window down here. It's the same exact command as we're running here. It just runs it inside my IDE. So whatever you like. And then once I have that running, I can hit a keyboard shortcut and boom, I can run them again. So I can write some tests, do some changes, Control R, and boom, run my test again if I want to. But again, that's specific to this IDE. I know we could show you in VS Code. Code has the same kind of thing. I think it's Control Shift P, and you can say go, and then like test all, run all tests. Nope. What is it? Test package? No. Go test all packages in workspace. Boom. That'll do it. I don't use VS Code all that much, so that's why I do that. But there are benefits to this as well. You can run remote servers and stuff with VS Code, which is pretty cool. So all the dependencies you might need could be out in a VM somewhere and not actually running on your local machine, which is kind of cool. But there you go. It ran all the tests, and those passed, and it's fine. Okay. So that's probably the main bits. I mean, I know there's running the test. If you run a make check, is it check all? I would do check all. Make check all will run the test, run all the linters, and run all the different bits that CI would run, which is super helpful. So if you have a linting issue, if you have a spell check issue, if you have a YAML that's not regenerated, any of those kind of checks that CI would run, this will do the same thing here. And this sometimes can be helpful to get around that CI workflow run where you make a change, push it, wait for CI to fail, run a change, push it, do that whole workflow. So here you can run it locally faster. So there's the linters running, the Go linter, the YAML linter. It validates the RBAC stuff, which gets generated automatically. It validates all the YAML bits that get generated automatically. And if you had an issue, it would break at some point in one of those bits. I think make install will go ahead and build the binary, install it in your path. So if I say which contour now, you can see this is the contour in my Go path bin. So now this is that one here. So I can go ahead and make a change, run contour locally if I want to. So now I could just say contour, and then there's the contour binary, right, that we just built. So you can iterate there quickly, and we can show you how that workflow might work because you're missing the Envoy bit, right? Envoy is the next piece that comes into play. So let's just do that. So to get Envoy, you're going to need Kubernetes because Contour runs against Kubernetes, right? You're going to need to be able to watch for secrets, watch for endpoints, watch for different things. The easiest way to do that is to run a cluster, and kind is a super simple way to do that. So what I do is out here in our examples, there's a kind folder, and there's this kind exposed port. I'm going to do it on keyboard, make that bigger. What this does is this spins up a kind cluster, and it's a one node cluster because it has one node here listed. And then we're going to map some ports to my host machine. And what's going to happen is we're going to map port 80 from my host machine to port 80 in the container. And that port 80 is the same port that Envoy is going to be listening on. So essentially now, once I do this, and let's just run it and then I can show you. But localhost 80 will map to the cluster. And what that will let me do is send requests to Envoy running in my local kind cluster, but without having to do port forwards. Let's go ahead and see if I have a cluster. I do. Let's just go ahead and delete those. Okay, so I'll do a kind create cluster. And what this is going to do is this is going to reference that if I always looked at this kind exposed port. So I'm just the shortcut, so I can do it from anywhere. So we'll hit OK. So this is a 121. There might be a new version out for, is 122 out yet? Like it's soon going to come out.
Yeah, I think it's out.
Is it out? Okay. Shows you what I know. So it's going to build a kind cluster here locally, which is easy. Blah, blah, blah. All right, there we go. So now I have a cluster. So if I say kind get clusters, you'll see the cluster here is Contour. If I do a Docker PS, this is where it's sort of interesting. So here you can see this port mapping. So localhost 80 is mapping to port 80 in my cluster or in my container, and the container is my cluster essentially. So 80 and 443 are both mapping into there, and this is my API server is what that one is. That's like a node port kind of thing. So let's go ahead and deploy Contour. So here's what I do. Again, there's a number of ways to do this, and this is probably something we could update, but I'll do a coup control apply off the examples, right? So the examples Contour is where we build all of our source binaries. That's this directory here. So here's where you get like all the service accounts and the configuration file, the CRDs, and all those sort of things. So essentially, this is how the quick starts are built. The quick starts are everything in this folder just smashed together into a single file to make it easy to reference. But what I end up with here is if I go ahead and get pods and project Contour, I have everything. I've got Envoy running here and I've got Contour running here. And this is fine. This will work. I can go ahead and if I apply, if I go to site, content, proxy demo, or what is it? Examples. This is one I always use locally. This is from a blog post I wrote like years ago. What that does is that gets me gets me some sample apps and some sample routes. So if I do local.projectcontour.io, what you'll see is the request comes into play. So this is actually Envoy responding. So essentially Envoy started with a host port of 80 because my Docker container is mapping port 80 on my host machine to port 80 in the container, then request to this URL, which essentially in our project Contour DNS routes to localhost 127.0.0.1, then this request works. And you get a fun, fancy, domain name that works there. You wouldn't have to do this way. There's a number of ways to do it, but this is just a super simple way to do this. Is that I guess that start makes sense to you, Orlin, in terms of how we deployed Contour? I guess we haven't done the dev part of it yet. Yeah. Okay. So now
so far I'm in the area that I know stuff.
Okay. No, you're fine. Yeah. So now from a developer standpoint, right? This is fine, but this is using. If I go ahead and look at my deployments, this deployment is using probably the main tag. Yeah. Right. So this is running off of that last change that Taro made is what's included in here. So every PR to Contour ends up with a new main image getting built and pushed out to the container registry here locally running in GitHub. So if you ever want to run like latest and greatest, even though we haven't released something, you can always test it based on using that main tag. Just make sure your image pull policy, which by default is always for this example. So anytime you delete the pod, you'll repull that image. Make sure that's set to always. Otherwise, if you've cached an old version of main, you won't get the new diff. But that's a good way to test it if you don't want to build it yourself. But what we want to do from a developer standpoint is actually change contour and then validate that that change is working quickly, right? And there's no ways you could do that. We could go ahead and build an image. So I could come into here, and I could say, I think it's like you add registry. Let's see if I have it in my history. Yeah. So I could say registry, new main. And what this is going to do is, this is a makefile task. This is going to go ahead and build a new image of contour, put it in the registry, which is my name, Steve Sloka, and give it a new tag called new main. It's going to build that and then push that to my local Docker hub. I'm not using GitHub yet for my local personal stuff. So what you could do is you could make your changes, build this image, and then update the image running in my kind cluster to be that image, and then you could test it that way, right? The problem with this is that it's slow, right? I got to build this image, I got to push it, I got to pull it back down to my cluster and do a bunch of things. You could probably simplify this by having like a local registry somewhere, like run your own Harbor instance or something maybe, but you still have the steps to build it and push it and pull it, all those different things. So what I guess what I'm going to propose we do is run contour on our host machine. And have the Envoy running in kind look at our host machine's contour for its configuration. So I guess we should step back in a second. Let's go to a document here. There should be an architecture, architecture guide here, yeah. So this one here is how contour works. So essentially, contour is the XDS server for Envoy. So if you're familiar with XDS, XDS stands for there's a talk at KubeCon we did a while back, but there are listeners, there are clusters, there are secrets, there are endpoints, all these different types of things all get bundled into this thing called XDS. And that's what Contour implements for Envoy. So it's a way for Envoy to consume protobufs, right, and get data over a gRPC endpoint. So Envoy, when it spins up, it gets this thing called a Bootstrap configuration. And what you'll see is, if we go ahead and look at, what's the best way to do that? I guess in the examples here, you could see it in the Envoy. There's a init container in here. Right here. This init container, right? And this calls this bootstrap command. And what this command does is this builds out essentially enough data for Contour or for Envoy to find contour in the cluster, right? So we give it an address and a port, and this is all default stuff. So Envoy is a pretty stateless thing, right? It just consumes this config and it says, hey, go find my XDS server. And that can be anywhere. That could be running in the cluster, running on a VM, a hosted service, something, whatever you want. So it'll spin up and look for contour. Contour will then provide all of the configuration to Envoy. So essentially what we're going to do in this scenario is that Envoy is running here in our kind cluster. We want to start contour on our local machine. And we're going to configure these Envoy instances running out here in kind to look at our local machine. So this way, when we make a code change, we just essentially have to run contour again locally and not have to build an image and push it and pull it and do that whole workflow, right? So it's a faster way to kind of develop. And that's what we're going to do real quick. So let's go ahead back to here. And I have a shortcut. I guess I can do it here since it's big. So what I usually do is I do a make install. Where is it? There it is. So I have this little thing here. So I do an install and then a serve. I'm sure you could probably skip the install. But essentially this contour serve command is what gets called from here. So if we look out here in our manifest, you'll see the contour container has an arg of serve, right? So here's contour serve, and this is going to run it in cluster. And here's the XDS address it's going to expose. So from here, we're going to run the same thing. I'm going to say, hey, contour serve. I'm going to pass it to kubeconfig from my local machine, which this points to my kind cluster. I'm going to make my XDS address my local IP address, which I think that's still true. I had an issue before with Linux doing this. We're going to run this insecure, which means we're not going to have the communication between Envoy and Contour secured over TLS. We're just going to say, don't worry about certs and stuff. That way we can avoid all of that struggle. And then we're going to pass the config file. And this is the way we can override things. So this is for testing like different options in the config file that aren't parameterized. So I have a little config here I can modify to play with that. Just make sure that this works. Okay, so here it's trying to run APIs, gateway APIs, but they're not installed. So my config file must have that turned on. So let's go ahead and turn that off. Yeah, so I have gateways turned on. Okay, so here essentially, here's Contour running now, right? So it started up, it's looking at my kind cluster, and it's ready to serve events. But what we have to do is we've got to change Envoy to look for our machine, right? So which one is it on here? I am 104. Okay, so we're gonna go ahead and edit the daemon set of Envoy, and we're going to change the XDS address in here. So we said that this Bootstrap config tells Envoy where to find Contour, right? So here we're going to change this from Contour, which is in the cluster, to be my local machine. And I'm going to take out this cert stuff, right? Because we don't want Envoy to run with certificates, again, to make this easier. So now essentially we're going to say, hey, Envoy, when you start up, look for this IP address, which is where your XDS server is going to be running. And then it'll connect. So we'll go ahead and do this. And then I have let's do a little force delete pods in project Contour. We'll do all of them. And we'll force it. Just trash them all, right? We can also scale our Contour deployments to 0 just for fun because they're not in use anymore. So now what we get is we'll have our instance of Envoy running, and then you'll see here this should connect. I guess we don't because we turned off the logs, but essentially because this went healthy, it connected to our instance. So we can go ahead and kill this. Let's do that delete again, and we can see this fail, I guess. So right now my XDS server is not running locally. This will spin up and it'll wait here forever because it's waiting for its XDS server to be healthy. So if we log the pod Envoy, the container Envoy, you'll see here the errors from Envoy saying, hey, upstream connection error. Can't find the person upstream. We're gonna just keep waiting for that to happen. Cool, does that make sense? So then we'll start up our server. That one. And then this will go healthy again. You'll see it connect after a second. So now essentially we're running off of our local instance, right? So I can come into Contour now and I can change any kind of code. I don't know what I would change, but you could change something in here to work on whatever you want to work on. And then you can rerun Contour locally. And essentially you'll be able to test those changes really fast. That makes sense. So we've talked about two ways, I guess, so far. One way is building container, pushing that container, and then running it in the cluster. That's helpful if you need like a real cloud. Like if I wanted to test like, how Contour works with load balancers or something, or I don't know, have it connect to an S3 bucket or something. Sometimes it's easier to do it in like a public cloud or in some sort of environment that's not local. You can, if you want, if you have ways. I think it's Tilt do this. Tilt and then the one from Ambassador, those folks. There's a way to connect your local machine to a cluster. If you can do that, then you could run Envoy, out in a cluster somewhere and have it connect to your local machine through whatever magic you want to do with that. And that would work as well. But this is just fast and easy. For most things, I think this is a good way you can do it. You can run this. Incidentally, this is how our end-to-end tests run as well. So if you want to run your end-to-end tests, essentially, this speeds up again that same workflow time. So you can run Contour locally in the the VM that runs the tests, and then all the tests will run in the cluster this way. Alrighty, so that's how to guys test and run, and then I don't know what else to say about that. That's all that is. I guess the code's the next thing. I guess what other questions about setup and environment might you have, Orlin?
I'm sorry, can you repeat that?
What other questions might you have about developing, or any local things that might be curious about in terms of local setup?
Like the thing that you set up with your IDE and stuff like this, but you show that already. So, and for someone who have been developing in the past, it's okay. I mean, I got everything that I needed. But for example, if we want to onboard someone new who is new to Golang, for example, how you showed the branching and syncing and everything. I'm not sure if we need something else.
Yeah, I don't know. I mean, some of the Go stuff can get tricky if you're not sure. It's made much easier now by Go modules, right? Because you don't have to live in a Go path you used to. You can kind of live anywhere on the system, which is kind of nice. So I don't know. Like, this is Linux, so it's gonna be different than Mac OS, which is different than my M1 Mac, because for my M1 Mac, I've got to download a different version. So if you say download Go, I got to come down here to this ARM version and download this one. It's an ARM-based system, so it's sort of like specific to what you're doing. But other than that, I mean, mostly if you don't have all the other tools, you can always wait for CI, right? You can push the change. You'll see this is a PR that Steve wrote. Every check, every PR push has the same set of checks that run. So it runs, the linting for you. It runs the code spell bits. It runs all the tests, and then it runs all the end-to-end tests. And it runs it for 3 different versions. So you run it for latest Kubernetes, N-1 and N-2. Again, all using kind. So you get like that matrix of testing. And that's based on this page here in terms of support. So what Contour supports. This should grow once we start doing quarterly releases, but in a sense, today we only support 3 versions of Kubernetes based on what client Go supports, and then 1 version of Gateway API. But I guess what my point is that even if you don't have all that stuff, you can just push your PR and let the CI do all the magic, and wait for that to happen if you don't have the other things installed. Yeah. Anything else you guys want to add, Steve or Sanjay? I'm not sure. I'm sure there's more I'm skipping over.
Did we want to also talk about like the structure of the code at all, Orlin? Is that what?
Yeah.
Also, like how the code is like laid out and whatever all the different packages are. We can spread it around also, Steve, if you don't want to keep talking. If you're
that's fine. You want to do some of that next, Sanjay?
Sure.
Yeah. Here, I will stop. Go for it. No worries. Yeah, that doesn't have to be me. You all know it pretty well now.
Let me. All right. So, I mean, I guess going top down from the beginning, I guess. So entry point into Contour is the command Contour package. Main and all the flag parsing and everything comes in here. I think what library do we use? We use Kingpin as a library for like CLI parsing, flag parsing and everything, and allows us to define subcommands of Contour and all the different flags that those subcommands take. Contour has, we can look at the Contour Now, let me move my Zoom stuff around. Oh, of course. So Contour has the subcommands. Help, of course, shows the help message, and then we have some more interesting ones. When Contour is running as an XDS server, we actually run Contour serve, and then that has a whole bunch of flags to configure how Contour's running there. The shutdown manager and the shutdown command are used in running as a container alongside Envoy to be able to gracefully shut down Envoy. The Bootstrap command generates Bootstrap configuration for Envoy. And if you want to use Contour to generate the TLS certificates that Envoy and Contour communication use, you can use this. Or you can also not even use this and use the cert manager controller component that the open source project. And these commands are kind of helpful for debugging or if you're testing out Contour to kind of see what subscribe to different XDS endpoints and see what resources they return. So that's all, like the entry point for all of that is configured in this package. So if you need to make changes to any CLI flags or anything, look there first to add the flag. This package may be refactored a little bit soon, especially the content around the serve command, just to how the Contour serve and all the XDS server and all the various components are set up. This is really the most like complicated file in this package, and has most of the content for setting up all the Kubernetes controllers and informers and setting up the Contour cache and the DAG. Well, I guess I shouldn't say DAG without explaining what that is first, but all the different bits that you need to start up to get Contour to start working. And pretty much everything else is in the, before I step into that, we have also the APIs package, which holds the different Contour CRDs that we build. So the V1 package, the GA CRDs like HTTP proxy, and also some generated content that goes along with that. And also the TLS certificate delegation CRD, which is another GA CRD. And the V1 Alpha 1 package holds some CRDs that are not yet GA. They're still in alpha status, but they're under active development.
Sanjay? Is it only me that I lost Sanjay, or no?
No, I lost him too.
Austin.
That's it. Show's over. There he
Can you
is.
hear me now?
Yeah.
Yeah.
Oh, now Zoom's telling me my internet connection is unstable. Wonderful. Where did I leave off? What did you hear last?
Sorry, I wasn't mute. On the V1 Alpha 1 stuff.
Okay, gotcha. Yeah, so those CRDs are under still active development. Changes happening there. If you need to make a change to a CRD, this is the package to look. One of these two, if you want to add. But we try to be strict about versioning for the V1 CRD. So CRD, like, so types can't change there really. You can only really make additive changes. You can't make remove fields or change types or anything like that. Unless we want to, if we need to move to a a new package version for a drastically needed like complete design change or field type change or something, we'll have to do a new API version. For V1 stuff, that's a little bit more less often. This should be pretty stable, only additive changes. And V1 Alpha 1, we have a little bit more leeway to change things since it's not a GA API, but most any super drastic changes we'll probably have to do V1 Alpha 2 or move forward, move a CRD to a different type. So yeah, when you make a change here, usually you'll add a field, add some Cube Builder annotations, for example. Let's see, what's an interesting one? So yeah, so this field says that it's optional. This is mostly for documentation purposes, this flag, but it's an optional field. You'll add some Cube Builder validations. You'll add the struct tags, field tags to so it generates. I'm not sure why this one has protobuf fields here. Typically, you just add the JSON tag like that, but and for example, for this one's got a regex pattern. So once you add a field, typically we have a helper. Oh, what did I just do? I don't remember what's the shortcut for just opening a terminal. I always have it open. Oh, weird shortcut. So typically you would make a change. For example, say if I wanted to add a new field to this. I'll make empty. And I would run make generate. Make generate, which will do all the generation stuff. I think we might have a sub. Not all generators are back. Oh boy.
We got a compile error or something somewhere.
I was doing something and I had an extra. Oh yeah, so generating the YAML documents and everything. So then we should see the change, this change reflected. We can add some documentation and whatever, and that should get reflected in here. So CRDs, what was it? Somewhere over here, right? So I've added a field called foo. I can add documentation that'll get generated in the description and everything. So yeah, that's simple, quick overview of that. What you typically do there. Configuring contour. So if you're making changes, we were talking about making changes to CLI flags or other things. If you're making other configuration changes to contour, the config contour takes a configuration file as one of its arguments. So, and the types for changing what the contents of the configuration file is in this package. This is the top level of that configuration file type. We're kind of transitioning to not so much using a configuration file anymore, but dynamic configuration via CRD. So until we completely deprecate the configuration file, if you're making changes to configuration for Contour, you'll probably have to add it for both this configuration file and in the CRD, or possibly in one place and not the other. I don't know if we have made anyone do that yet, if we've done that yet. Just add to the CRD and not the config file yet. Maybe that's something we'll start doing in the future when we're deprecating the config file. But yeah, this file, I mean, there's the types here. There's tests as well, simple Go tests that basically test that things are overridden properly or parsed properly or validated properly. Yep, so that's mostly it for that package. I think there's a little bit of, this is basically the only public like exported surface area besides the APIs for Contour. Pretty much everything else is in the internal packages. The other part of this that's exported surface area is some helpers around generating certificates that are people could use if they're writing their own Go code to generate certificates for the Contour Envoy communications to have their own tool. And I think this is also used in the Contour operator as well.
Yeah, I don't know that it's technically used yet, but that was the idea, was to instead of duplicating that work, have one place to do it, so it's the same.
Yeah, so this, I mean, if it's the case that it's not super useful, maybe this will go away. But we try to keep it as a publicly exported package, so maybe that's a little bit more complicated to do. But yeah, this is basically the main exported surface area of our Go code, besides the APIs themselves. The internal packages, this is basically where everything lives. That's actual main functionality of Contour. We have, what are the most important parts? We have the DAG package. So Contour, besides the interesting bits about subscribing to changes to resources in your Kubernetes cluster, this is kind of the most important and interesting part of Contour, or one of the most important parts of Contour. This is where we have all the logic for turning that configuration into Contour's internal model of like the state of the world, which is named as the DAG, directed acyclic graph. So basically a graph of the various resources that you configure in your cluster. So ingress resources that are for a certain domain that tell Contour that you want to proxy traffic to certain services, and those services have certain endpoints based on the number of instances of a deployment or something in your cluster. So this is where we build out Contour's like internal model of all of those Kubernetes resources into Contour speak. Basically, we have different I guess processors for these different resources. So when a change happens to, for example, a ingress resource, we'll see that change has happened and run that'll trigger the DAG to be rebuilt, and this ingress processor will basically look at all the ingress resources that exist, and in the cache of resources that we build from what the events that happened in the cluster, and then start building out parts of the DAG that reflect that information. So if you have like an ingress resource that listens on foo.com, that'll generate a component of the DAG that a listener in the DAG and a virtual host in the DAG, and attach all the relevant other resources. So that's what that's basically where most of the logic happens. So if you want to add a configuration on the HTTP proxy resource and see that reflected in some state that Contour sees and stays and then turns into Envoy configuration, the HTTP proxy processor, for example, is where you would make code changes. Some code changes to like pull that information out of the Kubernetes resource and save it. And then there's another component later, which we can talk about, that turns that into actual Envoy configuration. Anything anyone want to add at this checkpoint, I guess? Anything missing or extra information that would be useful?
No, that was great. I guess the one thing I would say is that, in my mind, the benefit of having this internal model is that, Contour supports multiple different APIs. So it supports, ingress from upstream. It supports its own HTTP proxy API, now supports gateway API. But having the internal model means that we can take any of those three APIs and convert them into a single common internal model. And then we just have to write one set of logic that goes from the internal model to actual Envoy config. So instead of having to go fully from, ingress to Envoy config, HTTP proxy to Envoy config, gateway API to Envoy config, we kind of separate it into two steps. And I think that actually makes the code simpler. Means so we don't have to write three different versions of kind of creating Envoy configuration. So it's definitely a benefit of having this internal DAG model.
Yeah, definitely. Well said. So yeah, I mean, if you're interested in making changes to Contour and how we process Kubernetes resources, this is kind of where you would look for things. So kind of as Steve alluded to, the other side of the translation to Envoy configuration is converting from the DAG to Envoy, like XDS API, and converting to structures that Envoy can understand. So the two of the relevant packages here are XDS cache and XDS package in the internal code here. What the there are, as in order to generate Envoy configuration, we have these components that when there are changes to the DAG, then they look at what the state of the DAG is, and then generate Envoy configuration for that. So we have kind of a different component for all the different types. So the clusters, endpoints, listeners, routes, secrets, etc. So and that's in the XDS cache package, and also the XDS package it contains a lot of helpers and things for oh no, that's not the right thing. It's the Envoy package. Contains helpers and things for actually doing conversions of DAG structures into Envoy structures. So for example, generating from a DAG cluster can generate an Envoy cluster. There's all sorts of these functions in here to help you to do that. So when you're wiring a change, so for example, if you want to wire a change all the way from like a new HTTP proxy field all the way down to new Envoy configuration, you'll probably be touching the APIs package, the DAG package, and possibly the XDS cache package, but maybe more likely just the Envoy package. If it's a straightforward change, you don't have to do too much refactoring or anything else. This package, the XDS cache package, you probably won't have to touch, I don't think. But yeah, I think that's probably true. Someone please correct me if I'm wrong. But yeah, I mean, I guess we could talk a little bit more detail about how other parts of Contour, like this internal XDS package itself, not to be confused with the XDS one, is where we have configuration for the and all the setup code for the actual XDS like gRPC server itself. So if you need to make changes to that there, and if you want to like wire up some changes there, that you could be touching that package. Yeah, and I think I guess it's hard to walk through all the different scenarios of changes you'd want to make, but that kind of covers the main, like that first thing we talked about, that kind of covers the main kind of changes you would make. And then there are also all these other packages that exist on the side here, which I feel like you would probably find out like by following imports and using the helpers from these. You would kind of learn about them that way. Don't know if we need to go into too much detail about the rest of these, but yeah, anything else we want to add here? Orland, did you have any more questions?
No, I'm cool. Just one question about the Envoy package. Is that something that we leverage from the Envoy people, or something that it's completely on our own?
Right. So we use all all these Go types here, for example, are from the Go control plane project, which is part of Envoy. So we're not rewriting all that's a project that like takes the protobufs that the Envoy APIs are written in and generates Go structs and everything for them. We just use those types. I don't think they have too many helpers around like creating, for example, like a type with certain fields, right? You just would use the exported fields on that type and create stuff yourself. But we have made this package to kind of wrap kind of all the common things that we would want to typically change. Like there's a lot of stuff that you wouldn't really want to change that often, and we can leave defaults in. And we have all these helper methods to create all those kind of quite complicated nesting of protobuf generated Go types and all the different fields that need to be set. Use these helper methods to create all those. And what ends up happening with all these different like Envoy, all the structs that are created is that we have the XDS server has a method of generating, basically it like on changes to the DAG and the output of the XDS cache component is that snapshots of Envoy configuration are generated, and that's what the XDS server, the gRPC server, sends back to Envoy on request. So you'll get that server will get a request to Envoy. The simplified version of how it works is it'll see the latest snapshots that are in the that have been generated for Envoy configuration and send that back to Envoy, and that's how Envoy gets configuration.
Okay, cool. Thanks.
Anything else? Any like other common things that we would want to describe about like places you would look to make changes if you're new to the code base? I think those are the main packages that you got to worry about. But
Yeah, main bits is just getting data from the API server, processing it through those builders, which makes the DAG, and then processing the DAG into Envoy config. There are the end-to-end tests and the feature tests and that sort of stuff, which to do a full or a complete, I guess, PR, it'd be good to be able to add coverage to those places as well that may not be apparent.
Yeah, that's a good point. So like all of these packages have unit tests like next to the source code, but if you want to do more, as Steve describes, more of an end-to-end test for things that you can actually reasonably observe in a request and response flow, or like routing between different services or something like that. We typically add end-to-end tests in this package here. There's kind of specific packages for testing like more specific resources that you might create. So these will actually run, as Steve described and before, as they'll run contour. Each test will run contour. Let's get it and show where it is on file. So these use Ginkgo so we can get kind of a nice like setup teardown flow before and after each test without having to build too much ourselves. But each test will run contour locally, and the test suite will run like Envoy and the required other resources to run in that are required to run contour in a kind cluster. But we'll run contour on your local machine, and each test will create resources in that cluster, the kind cluster. So for example, here we are deploying some fixtures for like a deployment and a service for an echo server. This is adding a self-signed cert, and we're making an HTTP proxy, and then actually making requests to the app that the HTTP proxy is exposing. So for things where you're like testing out how like features where request like response headers or other characteristics of a request and response are changed, or routing, or some details of like a TLS connection or something, you might write. It's something that you can observe easily in a test. You can write an end-to-end test here, and other tests where you kind of just want to test it's not so observable, or you just want to test that Contour sending the correct information and correct configuration to Envoy. That's where you would use this internal feature tests package, which let's see, what's an interesting one? I don't know. Where here we're creating this test suite is set up so that you can create resources, and they basically get added to the DAG and processed, and you can see you can query the output that the XDS server would send to Envoy. So for example, here, like we're adding a TLS certificate delegation resource, and we're then fetching the clusters that Contour would output and seeing that hey, we found a cluster and it has these values set and everything looks good, without us having to like spin up a full Envoy and everything, and then like get the config dump from Envoy and all that. We're getting it straight from Contour and kind of like a more constrained end-to-end integration-y kind of test.
You're pretending to be the Envoy client, and you're just validating that, hey, here's the configuration that I would generate. And if you trust Envoy does what it's supposed to do, then you don't have to worry about actually validating it. But that was the idea of these. But sometimes you can't do that, which is why the end-to-end tests are there, the actual ones where you query, But
yeah, for things where it's not just saying create a cluster or create a route or something, you actually want to make sure that, like, say if we wrote some Lua script or something that we're injecting Lua with, want to make sure that that is correct. And end to end, that's where you would use the other suite to actually do a real test. But
Okay, cool. A lot of things to read and watch that video again, so I can have some more questions.
sounds good.
I'm happy with the input. Thank you a lot.
Awesome. Yeah. So stop sharing my screen.
We're 6 minutes past the hour, but still, do we have some other topics than my newbie questions of how to onboard and do some changes? No,
I don't think so. No, no one else.
Okay.
No one else came. So
actually, it was real pleasure. Thanks for the effort to showing that, and I'll definitely have some questions, but I really want to be more active into this part, so at least to know it and not to be that ignorant of what you guys doing. So cool. Thanks a lot again, and then see you next week, I think. Thank you. Bye.
sounds good. Bye bye.
Bye.